Let's talk about LINQ in C#. We'll go over what it is, what problems it solves, how to use it. We'll look at examples and eventually learn what methods are available to us. LINQ is a syntactic sugar that can make your code more concise and readable. We don't need it, we want it. You can achieve the same thing with loops, but if you code a lot, you'll appreciate the shorthand. And you're sure to run into LINQ in the wild, so it's good to know even if you don't choose to use it all that much yourself. LINQ, of course, is an acronym that stands for Language Integrated Query. These queries in the C# programming language are for retrieving and manipulating data, which you can imagine is quite common. A query in this case is simply a request for information from a database or some other data source. The catch is that the request must be in a language that the data source understands. Keep in mind that sometimes we want data that resides outside of our program, such as from a database, an XML document, or a web service. The language integrated part of the acronym means that LINQ is built into the C# programming language, which addresses this idea of having to use different languages for the various data sources. When learning new technology, I find it helps my understanding to know which problems that technology solves. In the case of LINQ, queries were previously expressed as simple strings without type checking. You can see an example of a SQL query below. I say simple strings here just meaning the basic string type. You can see that these kind of queries are not so simple. They can be compound and much more complicated than what's shown. With type checking, we get a notification if we did something wrong at compile time. Without type checking, we only learn of our errors while our program is running in errors. Imagine if we misspelled the data collection's name or referred to a field that doesn't even exist. We also naturally wouldn't get IntelliSense support for queries written in a language outside of our programming language. If you aren't familiar with what IntelliSense is, it's a feature of integrated development environments like Visual Studio that helps with code completion and also offers suggestions when you run into errors and warnings in your code. And finally, if each data source uses a different query language, then we're stuck with having to learn a new language for each type of data source we want to use. So what kinds of things can we do with our LINQ queries? Some examples include filtering data. You can provide conditions that limit the number of items you receive from the original collection. For example, maybe you want to see temperatures above a certain threshold. LINQ allows you to order the data that's returned to you as well. You can do this in either ascending or descending order. In the case of text, you can have it alphabetized. There are methods for grouping data. Suppose you had a collection of employees and wanted to group them by the department that they worked in. We also get methods for aggregating data. The most common example would probably be summing values. You could have a collection of sales data, and maybe you wanted to add all of those values up to find out your total. You don't have to use addition, though. You're free to aggregate by whatever means you like. And finally, you can have your data transformed or projected from one type to another. So consider you had a collection of grades, and maybe you wanted just the letter representation. So like an 85, you might map to a B, a 92 might get mapped to the letter A, and so on. Let's talk about how to actually use LINQ. First, start by including the using system LINQ directive in the files where you want to use LINQ. Then just use quote-unquote LINQ to objects with types that implement the IEnumerable interface. LINQ to objects is just an official phrase that refers to calling LINQ methods on compatible types that are local to your C# program, like lists, arrays, dictionaries, things that you're already using. If you're wondering if LINQ methods can be used with a particular data type, just go to the Microsoft document pages for that data type and see if it implements the IEnumerable interface. Please note that LINQ with remote data is outside the scope of this course and won't be discussed here. So what is this IEnumerable interface mentioned in the previous slide? Well, it's an interface as denoted by the leading I in its name. That's a common naming convention for interfaces, and it helps us distinguish them from concrete classes. Also note that the T in brackets with the interface name is something we call a generic. The T here is just a placeholder for any actual type. It could be of type integer, string, custom type, you name it. Without going too far off topic and talking about interfaces, I will say they're kind of like a contract. They guarantee that certain methods will be available from any classes that implement these interfaces. In this case, the IEnumerable interface provides something called an enumerator. The enumerator allows us to iterate over items in the collection, processing each item in turn. And then based on the LINQ methods invoked and what parameters we pass to them, we can essentially do whatever we want with each of these values. Let's look at a quick example to hopefully bring the concepts home. The first line is our data source, which looks like it could be a collection of test scores. The LINQ query happens in this second section. You can see the IEnumerable type we mentioned previously. In this case, it contains values of type integer. You can then see that we're iterating over each of these scores in the scores array. The where score is greater than 80 part is one of those filtering conditions that we talked about before. It will prevent any scores that are 80 or less from appearing in the output. And then last, we see the select LINQ method, which returns the score itself. Recall that I noted that we can also transform or project the item in the collection to a different type or do whatever kind of processing we want on it. In this case, we just want to return the score itself. This third section of the code just allows us to see the results of the query. Note that the query isn't actually executed until it's used. You can see in that final output section that the scores 97, 92, and 81 made it through, and that the value of 60 was rejected, and this is all consistent with that where clause in our LINQ query above. Hopefully that's all clear to you, but don't worry if not. We're going to go through the LINQ methods in upcoming videos.